auto contact them. Normally, your admin side will contact them.
Yeah, you can email on your side, but once they hit, admin will only contact them should they not hit the percentage attendance.
Oh.
Yeah. I think less than 50% or 75% they will start contacting them. The admin side. Whether is it by call or by email.
No, because I need to know their partner.
Oh.
More importantly, are they going to do project here? If not, the mark cannot be given.
That's right.
Possible to say, is it right to say that the BFI, right, remain constant? Only the BFO only changes whether the forge on or not.
Because BFI also depends on your compressor, right?
Alright, a bit complicated. So once you reach 790,
Minus one. Why you minus?
no, because now this should be 0. Because now the pressure you reach 790, you're supposed to close off the compressor. This is by minute, so we need to find the time needed to reach 790 and time needed to complete the full minute to see how many pressure it drops. So we can't really like 2-4 minutes if it reaches 790. So you need to apply this formula twice. One to find the delta T, then another one to find the P2 again.
Delta T.
Yeah.
The closing point.
Yeah, correct. So the delta T to find is to find when it reaches the 790. Then next is you need to set the volume flow rate to 0, then to find P2 because the compressor stopped. Yeah, I already hit it.
So they got 2 times. I'm not sure whether 8.5.
So yeah, so I think what he's trying to say is this 8.5, right? I think it reaches 790. I think. It's on. Yeah, so it's shut off. Time is no, so it's very weird timing.
So the new compressor will be at 0.
This 0 is the flow rate, and this is the compressor stop already. So stop for how long we also need to find out until it reaches. Actually, this one I think is wrong because this one stopped already. Right? Must reach 620 before this thing kick in again. I mean, should be okay.
I mean, you can. I feel like you can just do key copy. The formula will be easier
Yeah, I mean I can just show for
No, it's not.
which one? Can just do this.
No, it's just I think this format is actually easier to see.
Oh,
The-
okay. Yeah, that's true.
But so the time that we do in minutes or do in seconds.
I think he do in seconds. That's why they use liter per second instead of meter cube per minute.
Makes sense. But per minute he also need to convert. You need to convert the minutes.
Yeah, so I mean we can stay at per minute.
This is the two. So what money cents per so this is the off one technically off one. So this
Actually that one I don't really understand. that minus thing. You go back check it.
let's see how this goes. FI is fixed out.
No, Fi is only fixed when the compressor is running. So if the compressor is not running, it's zero.
The
FO is fixed, yeah. Not really fixed lah. It's based on the minutes. FO is this one. The usage.
So the fee all depend on
But the VR is fixed, so I put on top instead of put here.
so I think the formula need to use for each.
Yeah. Well, this field no formula. All this no formula. Only P2 formula.
Then hydrogen is 14.9.
This one?
Hydrogen is 14.9.
Oh, 18.91 is this one based on this. The non-peak, that means when the forge is not using.
Oh, okay, I saw. The 326 is the big one, right?
Yeah, 326 is peak.
Okay.
Ours is 333. Then 2484 non-peak.
So the variable will be P
P2.
and P1.
Yeah, P1, P2. So actually P1 is actually P2, the previous minute P2.
Okay, more P and P2 again. Right.
More headache.
Done. This you got.
Yeah.
Then you got done.
I think tomorrow they probably want to start the assignment for the one hell. Saturday I saw Chinese. So you asked me what course I taking. I say yes, last Saturday I say taking the what's it called again? Thermal theory or something. Chinese say very easy. Then how's that? The rush come and say very hard. Walao eh. I don't know who to trust.
The more these are very hard to go through the many. At least the formula is straightforward.
Yeah.
Put the software.
I mean, if the test is online, then probably shouldn't be a problem.
True.
Class, let us start our lesson here. Alright, so I believe question 3 after my explanation, I believe most of you get it. Alright, so you just go back and then familiarize, alright, with this calculation P1, P2 actually. Right? So means what? Means you will use the P2 previous minute as a P1 for your next minute. Right? After you do few times, you know how to roughly you know how to actually get to the point. So you have to practice, not just copy, but have to practice. Of course, just now I showed the table is not 100% correct because it's previous student, right? Calculation might be wrong. I just want you to see how we actually do it nicely by using the table. You have to own calculation, cannot follow exactly the thing, but at least you know what to do. Alright, you know what to do. Okay, now we come to question 4. Alright, cooling of air and reclaim of heat. Alright, so in order to minimize work of compression, compressors are usually cooled either by air or water. For our project, given compressor is water. To improve volumetric efficiency, compression is often done in several stages. And to further reduce work, air is cooled between intercooler. Because inbuilt we have intercooler, because our compressor is quite big. Cooling air also reduces likelihood of spontaneous combustion of hot air and carry over lubricating oil. Due to steam and dry air partial pressure effect, warm air leaving compressor may reach 100% relative humidity, means what? Dew point. Alright, you will have water condensation. Right? And it cools further, significant quantity of water may precipitate. Right, means condenser. If this happens, pipe work. In the pipe work, the water can be loosened with tools. Some efforts are made to cool the air. Separate out much of water before enter pipe work. This cooling is usually done with an aftercooler. Right? All this heat has been removed from air can be either discarded or used for some purpose. So for our question, alright, they want us to send the hot water in the electroplating shop, which may be made to some extent by waste heat from the air plant. Alright, so over here, according to Australia standard, Victoria State, you are able to salvage 80%, alright, of the power, that energy that you supply to the compressor, right? You are able to use 80%, and then able to heat up water to 80 degrees Celsius. So this is a state of Victoria State that allow the factory to do this. So now come to our question here, question 4. Partner 1 and 2 do jointly, right? 2 marks. From the sample table of aftercooler provided, so I think we have seen this, alright? So which one do we select last week? The what? Aftercooler? Remember? Aftercooler.
HD16. HD16.
HD16, right? Okay, very good. HD. Right. And given here, for this aftercooler, if water enters at 15 degrees Celsius, at what temperature will the air leave it? Alright, this is part A. Part B, assuming large electric motor driving the compressor is 93% efficiency, determine approximately what percentage of electroplating hot water demand can be met by heat scavenging. Alright, so what does it mean? So first we have to look at the horsepower of our compressor, right? So what is our horsepower? If you look at the table, can you find horsepower
111.
from our DR4?
Wow.
111, right? Very good. So DR4 our horsepower is 111. Alright. So this is our shaft power, right? Shaft power. We have to convert to kilowatt. Alright, how to convert horsepower to kilowatt? What do you do? So actually this is called matrix.
Divide by 1.36.
Matrix horsepower. Because later on we want to find out the electrical power supplied to this compressor, right? So we want to find out in kilowatt. Alright, in kilowatt, what is how to convert horsepower to kilowatt? Matrix, and we call this matrix horsepower. So 111 times 1 over 1. This one you Google, you know. Horsepower to kilowatt, use Google conversion, you get it. So what's the value? Horsepower convert to kilowatt. From the table, from your DR4 table. DR4 your compressor. DR4. Yes.
When I Google, I got it 1.34. Is it power divided by 1.34?
1.34. What value you get? Do you have this?
I don't know, we Google, you were 1.36, mine is 1.34.
Oh, okay. So one is a British horsepower. One is matrix horsepower. So ours Australia they use matrix. Yeah. One is a British. So this is a matrix, Another is British unit. So different value, but close up. Different, but still different value. Right. Unit they use. So we stick to matrix. Stick to matrix. Okay, so in this case, so this one 81.6. Alright, kilowatt. Right. So what happened is our question asks, right? Okay, so our over here assume, right? Electric motor driving compressor 93% efficient. That means this is 93% efficient, right? So So for the electrical power supply to motor, and motor have this efficiency of 93%. So what will be the original power supply to this compressor? Greater or lower? Greater, right? Okay, so what will be the value for this kilowatt use? What's the value for? Alright, very good. So roughly, electrical. Seven, 4 lah. Okay, so we are going to salvage, right? According to these the guidelines, 80% can be used, all right, to actually deliver 80% of this, all right, for salvaging.
Okay, I see.
Oh, so this one
So
is
what's
trying
the
to
value
say
we
this
can actually
81.6 is 93%. So we need to find 100%.
Very good. So we round up, 70. Okay, until now, who still cannot get the idea why we do this? 87.74 is this. The electrical power to the compressor.
Sorry, what's 0.8 again?
This 80%.
Oh, okay.
Because they allow us to use 80%. Alright? Draw the heat and then to warm up the electroplating workshop. Or the heat bath. For the metal pieces. Anyone still have no idea what we are doing? Oh, okay. Alright, so for your part, according to the table, after you calculate, right, how many times compressor on off, right? When compressor on means what? Means you are able to generate heat, right? Compressor off, there may no heat generated, right? So you have to find out the cycle, right? And then you multiply what will be the heat generated by the compressor. Alright, then you know the exact figure, what it will be the heat generated. So depending on how long your compressor actually on. Okay. So later on when you go back, right? When you go back, you know that you calculate out the compressor on time. Then you will have this roughly about this figure, plus minus, very close, supposed to be, because according to your list, your compressor always on, probably a few cycles off. Most of the time will be on. So quite close to this, quite close. Alright. So next thing will be how much heat can we draw? Alright, how much heat can we draw from the inner cooler and outer cooler?
We split.
No, was supposed to. I think the video break a lot of parts already. But because just now I recorded, then I stopped, then I think there was.
Okay, so we talk about mass flow rate, right? This mass flow rate, where can you get the mass flow rate? Where can we get this mass flow rate? Cv specific heat, this one specific heat. And then this is the temperature range or temperature change. Alright, so from our remember initially our workshop, electroplating workshop, they mentioned about the temperature, right? If I'm not mistaken. Okay, over here, right? Electroplating workshop. Alright, I need you to pay attention to this. No compressed air is used here, but there are baths requiring hot water. Requirement is 2.7 meter cube per hour of water at 60 degrees Celsius. Water enter the premises at 15 degrees Celsius. Alright, so what would be the 15 to 60, right? What would be the temperature change? 45, right? Right, 45. So in this case, what does it mean is changing, the changes of 45 degrees Celsius, how much heat do we need? How much heat do we need to heat up from 15 degrees Celsius to 60 degrees Celsius? How much heat needed? So we apply this formula, heat needed. So this one with 45, right? Specific heat. If you Google, you know water, right? Specific heat, right? Okay, now we come to this mass flow. Right, where to get the mass flow, right?
But this one is for metric flow rate.
Okay, it's density.
Oh yeah, density.
They convert it as heat transfer.
I forget already.
Density.
Okay, now we take a look at this. Our compressor DR4, cooler. Alright. So this is the volume flow rate, right? Correct? Alright, so for compressor we have 1 meter cube per hour. Okay. How about after cooler? Remember after cooler? HD16, alright? DR4. Okay, so over here, you can see after cooler we use for DR4. Water consumption 1.7, very good. So after cooler 1.7. End up will be 2.7, right? 2.7 per hour. So this is mass flow, right? This is the volume flow. So to convert the volume flow. For water, right? Anyone can share how to convert from the volume flow rate to mass flow rate? Okay, very good. Huh?
By the 600.
All right. So this is the density, equal to the mass, right?
So the 2.7 is still for the question, right?
No, 2.7 here is intercooler. You have 1 meter cube per hour from your DR4 table.
But the question also got 2.7.
Yeah, because they add the 2 lah.
Oh, so then where you get the 1.7 from? The 1.7 where you get?
1.7 after cooler HD16. HD16. Depending on the compressor. Alright, so volume density of water, you know, right? Density of water, right? Density of water 100 kilograms per meter cube. Alright, so we want to calculate kilogram per second, right? So from hour we want to get second, right? Okay, so what will be the mass, mass flow, 0.75, right? Kilo per second, right? So what is the heat needed? So now we can calculate the total heat needed to warm up the water to 60 degrees Celsius, right? So you just plug in because this is mass flow rate, mass flow rate. Your specific heat of water, you know, alright? Times your 45. So this will be the heat needed, salvage 80%. But depend on your calculation for compressor on cycle, right? So we only can provide this much, right? We can only provide this much. So what we need in order to derive 80%, we cannot meet, right? But at least we can contribute partially, not fully, right? Partially. So we have to calculate the percentage out, right? How much do we still need in order to salvage 80%, right?
It's 15 minus 60 minus.
So final question, because when you go back, at least you have idea how to approach this question. I just explained to you the overview. Calculation, you have to do it yourself.
Said the electrical power we need to account for the 70.2, but we need to compare 70.2.
Sorry?
Because the heat also kilowatt. Heat.
But we need to we really compare that to the total amount, right? So the total amount we get.
Your total amount is this total.
The QR.
Because this one is based on 80%.
Then the specific heat, right? We need to see from what temperature, right?
Specific, yes. This one, definitely you can find out the water specific heat.
That one we take from the average temperature, is it?
Average 15 degrees Celsius.
15, we take from the initial one.
Yeah, 15 degrees. Kilojoule per kilogram. Water one easily can be found. But at least you know the idea behind, right? You provide electrical power to the compressor. 93% efficiency, right? So we are using this to generate the heat, right? So this heat amount is like this. We want to take 50% if possible to warm up electroplating workshop. But the problem is we don't have 50%, right? We only have a lower percentage. So you have to find out the difference. What are the percentage? The difference. How much can you salvage at the moment with our compressor?
So after we calculate the total amount, we need to check how much more power is needed, is it?
You can, so the report, okay, now we come to the how you write the report, right? So imagine you are the engineer, right? Engaged by the client, engaged by the client, customer. So how you write the report in order to impress, or not so to impress, but to show the customer or the client that you actually do your homework. You actually do the calculation to prove why you have to install this and that, right? So you have to write in the way, like a report form. So question 1, new page, question 2, new page. So that as a client, I can see and read easily. Because previous school, what they do is they cut and paste the Australian standard. Then everything Australian standard. As a client, I do not need to refer to Australian standard, right? You just need to quote, okay, in accordance with this clause, alright, this Australian standard, after that the report, the calculation. Don't go and copy all the statement. Alright, mean nothing to the client, mean nothing to customer. I waste my time reading all this. But I want to know the source, where how you code it, right? You have to code the source. Alright. Clause don't know what, according to Australian standard. Then after that, all this requirement needed from the question. After you finish one, followed by new page for new questions. Right? Of course, you have the right introduction now, the starting right introduction, what is the requirement, what is your responsibility, you have to mention.
I sound so professional.
I want very jumper.
Alright? Any questions so far regarding question 4?
Question. Yeah, wait.
Should be can.
After we get the heat, what's the next step?
This module
So the heat is the total heat amount, right? You have to make sure that the heat generated by compressor definitely cannot hit because if you calculate, it's roughly about
yeah, but
this figure,
if you
much
can
more
refer
than
to the old one, then okay lah.
much more than this.
I ask you to write everything down. I cannot.
Right now, how many percent can you
Yeah,
see?
I need to convert that into joules first.
Not necessary because here also kilowatt.
Oh, okay.
So that's the ratio, percentage. How much I can produce, how much I still need. Okay, so now we come to question 5. Alright, question 5. Pressure relief devices. Alright, so pressure vessel filled with compressible gases or vapors can release large amount of energy if explode, right, due to over-pressurization. Control system aim to ensure the source of energy causing the rise of pressure is deactivated when pressure has reached desired upper limit. So just now we mentioned, right, we talk about the design pressure or set pressure. So remember what is the value we discussed just now? Our compressor must stop at 790 kVA, right? Alright, so remember compressor off. $790 kPa. Your maximum working pressure for the DR4 where's the 862, very good, 862.5 kilopascal. So we will take, for simplicity, we will take this maximum working pressure as our set pressure, also equal to set pressure. So what does that mean is, for if let's say our compressor failed to stop, alright, so it will keep pumping air. In this case, alright, the receiver become pressurized further. So our safety device at 862.5 kilopascal have to release air, or the valve have to be opened. Alright, so we have discussed just now. However, such control system can fail and should be backed up with pressure relief valve that allow excess gas to escape when pressure is high. Such pressure relief valve must be able to handle full flow generated by compressor. Vessel may also experience rising pressure if exposed to unintended source of heat. Alright, so this is scenario 2 we discussed just now. Alright. Okay, so source such as fire and must be fitted with pressure relief valve capable of releasing sufficient air or vapor to prevent pressure rising excessively. In event of extreme fire, temperature rise of metal from which vessel is made may be sufficient to cause metal significantly weaken. To prevent explosion in such situation, temperature activated relief valve need to be fitted. Alright, so second, this is first scenario. Compressor fail. Second scenario, near fire. Alright. So what will be the 1.1 no 110% of P62? Our safety valve. What's the value? 110% of set pressure. Nine four eight, very good. 948 is
PS1.
Alright. So we have to look for this safety device
Oh, yeah,
that can release air at 948. Alright, okay, now we come to the question 5. Just overview, they actually give you some overview what to do. Now we come to this question 5. Before doing detail, okay, partner 1 and partner 2 do A, where's A? Do A jointly. Where's A? I think they put the A missing. So this is part A, part A. Part A bracket missing. Alright, so before doing detailed calculation for this question, confirm with lecturer, tutor that your choice of compressor and receiver size are acceptable. That's why I want to repeat this. If your compressor and receiver size is not or deviate too much, I can't help you because all haywire. That means you calculated wrongly, right? From sample table of a safety valve provided at the E reserve address given. So you got time, you go and I don't know. Can you access activity again? Cannot. Can you? Last week I believe most of it cannot, but this week can. Canvas activity. Still cannot. Still cannot. Then I will post up. If let's say cannot, then I will post appendix 3A today. Right? Suitable for protecting receiver from excessive pressure that could occur if compressor pressure control failed to deactivate compressor appropriately. To identify the valve and its pressure setting, give reason for your selection. Alright, so please refer to Australian standard. By the way, can you see Australian standard as well? Anyone already downloaded Australian standard 1 to 10?
No.
Nobody downloaded. Then I will post again tonight. So this is A. Alright, this is A. 1 and partner 2 do jointly, right? Partner 1 to do B section 1. Partner 2 do B section 2. So you will see.
That is 2.
Over here, in the event of fire occurring near receiver, the heat input to vessel cause pressure of air to rise. If compressor has failed to turn off, discharge capacity of valve chosen in A may be inadequate to deal with this situation. Why? Because of fire, near fire is this. Alright, our set pressure is 862. But now, near fire, it will rise up to 948. Alright, so for situation of near fire, where design strength of vessel has not deteriorated, determine requiring of discharge in kilogram per second of pressure activated relief valve to deal with situation. The pressure at which this flow may occur. Alright. The pressure setting at which this valve is to open, and from sample table of possible safety valves provided. Alright. So you have to look for the correct or proper safety valve to use. Okay, now we come to this part. Assume thickness of corroded vessel is 6 to 8 mm for purposes of this question. This assumption may require revision when more detailed vessel design is carried out in part B. Assume minimum operating temperature is 15 degrees Celsius, 288 Kelvin. The vessel will be made of low carbon manganese steel, boiler quality plate, manufactured accordance. So this one is meant for this scenario B. So the partner 2, right, then we have to do this Alright, subsection 2. In the situation where fire has caused temperature of vessel to raise sufficiently to cause strength of metal to be weakened. So just now I showed the chart, right? You have to plot the chart and then find out the relieving temperature, TR, relieving temperature from the chart to do this question.
Yeah, sure, the chart again.
Okay. Okay, so I go back in order for you to see.
Question 6, last question.
What is last one?
Question 6, last one.
Oh.
I got enough.
This is the chart for those partners who that need to do this question. This is how you use this to retrieve or to get your relieving temperature.
We finished like 1 week early, then got the next assignment.
But we got 1 week break. Tuesday.
Oh, yeah. Next week.
Alright, so this is how you get your relieving temperature. In order to use this formula, because this formula requires you to use this TR value. For partner 2, I hope you take note of this. So when you go back, you are able to proceed with your questions. Alright. Okay, so I have some exercise for you to familiarize with these questions. Let me find it.
Better not if homework.
I don't know.
Okay, so when you go back, this is the safety device, right? That you will use, right? You can see over here, 1541, 1543, safety valve. So 1543, 1541, model. Based on 10% overpressure and 90% of average capacity, calculated in accordance with Australian standard. Capacity in liter per second. If you ask why later on we have to change to liter per second, right? Because this one, the value here is in the liter per second, right? Because we talk about mass, right? Remember just now? We talk about all these, all these, all right? In mass flow rate, mass flow rate. We want to convert to volume flow rate. Alright? Because why? Because of safety device we use liter per second. is a volume flow rate. Right? Volume.
Closed caption.
So we have to apply this formula. Huh? Okay, so over here you can see, if you read your question right, they talk about orifice. Alright, orifice surface area. Okay, so this is must be more than 10 mm. Alright, so this is a surface area. You have to find diameter, right? The specified diameter is more than 10 mm. Right, so you have to find the proper, proper orifice to use. Depending on your set pressure. Remember what is our set pressure? Alright. But exercise, now just to familiarize. Okay, we do this question 1 and question 2. In model 1543 with inlet size 25, this one 1543, yeah? This one is used as safety valve. Determine the interpolation of air capacity in liter per second when set pressure is 415. So in between here, right? Because later on you have to do interpolation. Because nobody will get exact value. You might have, the variables in between. So how you do interpolation? Okay, so now this is 1543. Right. So we are referring to this part. So we spend 5 minutes to do this. At least you get the idea of how to get interpolation for this safety device in liters per second. Anyone have difficulty digesting this question? The idea is we want to find out the safety device used for our air vessel. Right? Our set pressure already determined because from our compressor DR4. Right? 110% of set pressure is this value, right? But now in order for you, when you go back to use this to find the safety device, right, we do this exercise. When you go back, apply the same thing, same approach, then you will get your value, correct value for your answer, right? So now we try to exercise a bit. You know what to do when you go back.
So the safety valve will be at the receiver, is it?
Yes.
So the one that we are reading there is what's coming to the receiver, basically.
Yes, receiver, correct. Because what happened in this one? We're talking about receiver, compressor, right? Imagine now your compressor failed, keep pumping air, right? So you must have a safety device here, alright? One is for this, another one is for fire. This is for fuel compressor. So it depends on your design, right? Another one is for near fire. And then the partner two will have fire. But to find out this, you have to know how to use this table. Alright, so let us spend some time. Then go back, you can sleep better.
This is about 120.
Mr. Ashraf is not here, no? Mr. Ashraf. Because I don't see him log in, right? Mr. Pradeswaran. Pradeswaran also not here. Mr. Takashini. Anyone know Takashini? Edmund Ng. Edmund Ng.
Okay, I know you. This one, right?
Muhammad
So it's one
Amiru.
copy, but
Amiru.
do it.
But he say it's size.
Muhammad Ashraf.
He say it's size 25, so it's this one. This one.
No, this one is.
No, but eh?
Anyone
okay, okay.
know the name I mentioned just now? Your classmate, your friend? Can you inform them or update me where are they about?
So it's in
What?
between this one.
Oh,
So we
okay,
put
okay.
in this.
183.1 and what?
1, 2,
201 point 1.6. Okay. What is this one? This is mm, is it? No, this is liter per second. Yeah, same. Square.
No, it's this one.
It's area unit. Yeah, I think it's liter per second because he point the arrow for question. Then it's like you want to find 35.
Regarding the 30 of per second. This table is.
Liter per second.
Sure.
Anyone get the question one value?
The liter per second is the middle.
Yeah, liter per second is.
188.68. 188.68.
188 point. Okay lah, acceptable. 188 point something.
You take the set value. Wait, so why?
Alright, so for those who have
Let's say
issue
for this case, right, we want to find
with
pressure. So why is
interpolation, right?
why is the not the pressure, the air capacity, right? So y1 is the first value air capacity, which is 183.1. Then x is the pressure. So x is your set pressure. That means 1.
Alright, so this is how you
For one
carry out
point.
interpolation. Similarly, for your question, right?
Yeah.
Also do the same.
What's so different?
By the way, coming Monday we will start
But
class.
his
Right?
answer is
Coming Monday, yeah. So don't forget, not Friday, Friday off. It's a public holiday, right?
Supposed to be
Diameter.
I think it's
Now we have to calculate out. You see the question, right?
Terbalik lah. This one just swap only. This is just a turn over then just plus this.
I think from our
Change swap around. The x become y, y become x. So fast.
Monday. Again.
No, Monday class. Fast right? What the fuck? We just study after that. Just to like
Few days only. What the shit?
that's 78.
Oh, that's a big impact.
okay. The NNM is actually specified in the AS Australian Standard 1210. If you look carefully, right, it actually mentioned about must be more than 10 mm. To prevent sticking, because too small the area, right, it might actually subject to contamination or corrosion. Let me check whether subsequently
Oh, they haven't checked yet. I forgot. Suddenly, my brain cannot work. Oh, maybe it's this one. Go back and see video and try again.
the paragraph didn't mention about 10 mm, but if you go to this Australian Standard 1210, they actually specify more than 10 mm. Yeah, good question, 10 mm. It's actually derived from the Australian Standard. The diameter. Okay, so now the thing is, if you cannot find, alright, if let's say now after you select the safety device and the diameter is smaller than 10 mm, right? So what can you do? You have to change to other safety devices to meet the requirement. Because Australian standards say more than 10 mm, we have to conform. Then you have to suggest alternate means another safety device able to discharge become the overpressure at the same time meet the ball diameter. Alright, so this is what we do. Any issue with question 2 or not? Question 2 is on the other way around. You find the set pressure. Alright, given the flow rate, alright, then you are able to find the set pressure. Vice versa. Okay, any question related to interpolation and finding out safety devices? Alright, if no question, let us go through. As you know, right, today we are supposed to cover all the project A, right? Project A questions for week 2. And the last one will be piping, right? Piping.
See the position from here.
That's not the one.
If you have a time, then go through all these slides yourself, right? Showing
the
us
Google.
safety valve used for various type of applications.
Yes.
Where's the efficient?
Alright, so topic 4
This one is
is
correct.
piping.
Okay lah. I think the how you do it is
I think the first one I do is wrong.
Alright, so piping,
which the different one
for us we also have the design piping according to our requirement here. Let us take a look at the requirement. Okay, so you can see from here, distribution of air to tools. Alright, so after our receiver,
This one,
Right,
this
output
one
go to the-
don't make the answer.
forge,
doesn't say
Right.
how they
and then various workshops. Altogether, we have 6 workshops, right? If you look carefully, how many workshops do we have? Alright. So we have fettling shop, machine shop, assembly shop, paint shop, electroplating shop, packaging department. 6 workshops, right? 6 workshops. Over here they show us, alright, the requirement. So you have to, this is just for overview. When you design, you have to install fittings, alright. And then also at 30 meter, there's a drain line, alright, to drain the water out. Alright, so this is just for a guideline showing us how you run your piping. Alright, so this is our air receiver, check valve. Then over here on the let's say I look at this way, on my right, fettling shop, machine shop, paint shop. Alright, on my left, I have a forge, assembly shop, and packaging department. So following the distance over here, right, the distance drafted here, then you have to calculate pressure drop. Alright, pressure drop towards the end. Also, you have to meet the velocity. Alright, required, I think 6 meters per second. Must be more than 6 meters per second. Alright, so later we take a look at the question, but give you some idea. You need to actually draft this on the report. Alright, and this is JKIH. So depending on the partner, later you will see the question asked, depending on your student number. So over here they actually show some of the distance. Alright, so your student number, use your student number and your project partner number to determine the length of HIJK. Right? So given is this, depending on your student number, so everyone will be different. Okay, so let us take a look at the requirement here. Alright, so decisions that engineer designing piping may have to address: the internal diameter of pipe, deciding pipe material, associated joining methods and materials, deciding thickness, deciding location, deciding method and frequency of support, allowance for expansion, deciding pipe should have slope for drainage of water, Deciding if expansion joints are necessary for pipe material. Decide if thermal insulation is required. This one especially in Australia, right, they have winter ice form. Just like, even like for us aircraft, you know, right, we have a student from Moscow. So he shared, during winter, right, you know what's the temperature in Moscow? Minus 41 degrees Celsius. I don't know how he survived, minus 41. So what happened is, even aircraft on ground, you have the on heater. Have the on heater because 41 become ice. As you know, the pipe if vessel become ice means what? Rupture, right? Expand and rupture the thing. So even aircraft on ground, they on heater just to prevent ice from forming. Minus 41. So in this case, it's true because in Singapore we don't have all these issues. But Australia, Russia, talk about this. They have to properly insulate the piping. For aircraft also the same thing. Our aircraft also, all the piping is insulated with this heating element, right? In air, right? So what is the temperature in air, roughly? Cruising speed, what is the temperature? 36,000 feet. Let's say you go holiday, right? Up in the air, right? 36,000 feet. Minus 56 degrees Celsius. Right? So all without heating, all become ice. Alright, so decide if thermal insulation is required. Decide what control and processing fitting should be incorporated. So our course note actually have explained the fittings. So please take a look and decide what fittings you need to install. Alright. So over here you can see the distribution. Partner 1 do A, 1 mark. Partner 2 do B, 1 mark. X and Y are defined, okay. If X and Y are number, then partner 1, partner 2 do C together. If X, Y even number, then you do part D together. Alright, so that you prevent you from copying. Okay. So the route of main compressed air line is shown on the next page, what we have seen just now. Okay. Okay, now we want to take a look at this, the requirement here. The objective in question CD below is to determine appropriate internal diameters of various sections of main pipe. So what happens is this, you must understand. The pipe size is different. Here, higher velocity, right? Slowly go toward the end, smaller the pipe. Because of the demand reduced, right? Over here, the demand is more because you must cater, right, at this section. Alright, from the receiver, you must cater for the downstream, right? The total demand. So the pipe has to be bigger. Come to this fettling shop, then you will reduce the pipe size for the machine shop, and then the smaller size for the paint shop, because the demand gradually reduce towards the end, right? So over here you must make sure, must accommodate forge, this part, forge assembly shop packaging department. Not the same size throughout. It cannot work. Must be from the starting point bigger toward the end smaller pipe size. Alright, so this is the requirement. Okay, then over here, leakage in each workshop is estimated at 5 liters per second. Okay, so this one you need to include, because altogether we have 6 workshops, right? Each workshop estimated leakage is 5, so error will be 30. So each workshop please include 5 liters leakage. 2 commonly accepted guides for compressed air piping. The velocity in the main pipe should not exceed 6 meters per second to avoid entrainment of water. So you must find out the diameter, pipe diameter that do not allow velocity more than 6 meters per second. Alright. After that, the frictional pressure drop between compressor plant and furthermost point of use should not exceed about 30 kilopascal. Means towards the end workshop. Alternatively expressed as 5% of the applied pressure. So this is what happened is a 30 kilopascal, right? Remember our minimum 620 minus 30, right? 590, you still have remaining 590, right? For this assignment, you are to size the pipe so that when pressure at the branches of receiver outlet T piece RT is 620 kilopascal, right? So remember the table that we discussed now come into picture. Right? That's why remember we must make sure receiver must have 620 minimum, because to the workshop and forge we need 590. Alright. So the frictional pressure drop between RT and branches to packaging and paint shop no more than 20 kilopascal. So add up will be 30, making the pipes bigger than need be increases capital cost. Okay, so of course you must make sense. If you want to use bigger one thing is better, right? But in the real case, actual fact is as an engineer, right, you actually your customer complain, right? Why I have to pay so much? Making them too small means to give required pressure downstream at the tools higher upstream pressure will be necessary to compensate for frictional loss. Right, so you have to find the right size. Within workshop, the pipe usually terminate at chest height with isolating valve, combined filter, water separator, pressure regulator, gauge unit, and then post connection fitting. If the driven machine requires lubricant to be added to air, fit lubricator is also fitted. So you have to include the fittings in your drawing. So after that, part C, determine the minimum acceptable nominal bore pipe sizes for 3 sections of main pipe between relevant outlet of the T receiver and the branch to the packaging department. 3 sections are indicated schematically on the next page. Right, so over here. Okay. So over here you have to calculate frictional pressure drop less than 20 kilopascal. So the bore size of your pipe. Likewise for D, so depending on your student number, right? So odd number, even number, you have to the section given to you have to select. Alright, so the end of this one, your report on part A, prepare jointly with your partner and indicating on front page who is partner 1 and partner 2 respectively. Logic must be clearly shown, reasons for decisions clearly stated, sample calculation must be given. Alright. So those are the requirements from the project E.
Let's just part A.
Submission validation. Validating calculation. Means that cousin is submit.
Sure.
Submission validating calculation. And like
Straight drawing submission.
So now we do some exercise for piping. Right? Give you some idea how to go about doing this. Alright, so let us do this exercise here, relevant to our question 6. Alright. Determine the minimum acceptable nominal ball pipe sizes for the 3 sections of a main pipe between the relevant outlet. So over here, this is what we see from the receiver. Alright. So over here, I mean, your project, you must include all these. So leakage must be less than 20 kilopascal for all workshop. This side receiver leakage assumed to be, this one for your case, for this year 2023 is the workshop according to question. Use a general gas equation, right? This general P1 V1 equal to P2 V2. So V1 is the 2 consumption, right? And then the pressure P1 is the atmospheric pressure. Then P2 will be your system pressure, right? So you have to use this system pressure with the leakage just now 15, right? One side. You see, one side is here, right? Each workshop we have 5 this kilopascal drop, right? 605, 605. Then find the V2 for each workshop. Okay. This is how we find P1, P1. Alright, so your P1 is atmospheric pressure. P2 is your 605. So this is a volume flow rate. So how you determine volume flow rate? Over here they show us velocity times area. So what is your velocity requirement? Yeah, cannot be more than, that means less than 6. 6 or equal. If you find equal means the maximum size. Or I should say the minimum size needed. Alright, so using this at least you know velocity, area, surface area of the pipe. Then from there you can find the diameter.
Sir, is surface area the same as cross-sectional area?
Ah,
Okay.
Alright, after that check pressure drop for each section. In order to find density, alright, so we use mass over volume. So later on you have to find this, alright, this pressure drop using this formula. Or head loss, we call this. So diameter you can find out right from this, the previous one. And this is from the Reynolds number. They call this as a friction factor. Then to find this Reynolds number later. C velocity, D will be diameter. Your mu will be dynamic viscosity, density. So all these are relevant info for you to do these questions. Alright, so for your case will be total leakage is 30 liter per second. Each workshop is having leakage of 5 liter per second. Alright, once you figure out, the next one will be the table used for us to find, right, the size of the pipe. Alright, follow this table, 6.7.6, Australian standard 1074, medium and heavy tube. Alright, so you'll find over here which type of pipe you use, threaded joint, or welded joint, or screw, flange joint. Right? So it depends on the application, you have to explain which one you use. Right? Depending on the velocity, right, that just now you calculated. The pressure drop as well. And then you will find the one that most appropriate to the project. So over here you can see nominal size. Alright. In mm, I think this is mm, right? Okay, over here they actually show how do we determine? Right? How do we determine? Because later you have to find out this inner diameter. Alright, so over here, let's say now this is 20, right? 20 is a nominal bore. Outside diameter 26.9. Alright, so the medium is what, 2.6. So what will be your inner diameter? 26.9 minus 2.6 plus 2.6. Alright, so actual one is 21.7. So after the selection, alright, you must actually use this actual by selection that you selected, and then try to and actually use this to test whether it's less than 6 meter per second, lower than 6 meter per second. After you selected the correct size, you must make sure that it's not more than 6 meter per second when the velocity. Okay, over here we have this. Alright, in order, just now one of formula. Alright, dynamic viscosity, right? Dynamic viscosity you can find from this. Also, one of the appendix inside your this from canvas. Right, so we are able to find because our reference temperature here is 15 degrees Celsius. You must use this value when we do your this question. And also over here, alright, the material. Alright, material you use, you must also include this absolute roughness, the epsilon 0.15. Use this value for your pipe internal surface, so that you're able to use this to find the friction factor. Right. So this is the one that we find out. Epsilon just now we use diameter to find out this value. Then from this chart you are able to find the factor F factor. So basically we want to find the rough, right? Okay, next question related to question 6, piping.
Where to get this information? Where to get this information?
Now this is from activity 1. You know the given activity. All the activities they actually have all this info. But I will post if I say for those who cannot download. But did you refer to Kaplan why you cannot download from RMIT?
Yeah, we don't even see it. So if you are going to repost it, will you repost it with the red subheadings?
Okay.
The red color thing just now, all the notes.
No, that one no, this one can.
Then could you go back to the, I missed on this slide,
Which one?
the very first one where you had all the formulas for question 6A. This one. Can you zoom in to the right?
Zooming to the right.
So we can all,
Zooming to the right.
yeah, right side. Because it's a bit blurry.
Different from my side.
I'm sorry.
But this is just a guideline. You have to plug in your own value.
That's quite
Right, so since we still have time, right, I want to show you
This
I come to this exam.
Question was here.
Pay attention to this. Come
2D
to
and skip C，我们是 D，
Oh, so we don't need to do C?
I don't really know C.
Oh, that's good.
But D determine the yeah, I think the same. Because it's or different department lah. Same scenario but different department. This
Okay,
one.
although this topic one, right, not related to our project, because our project didn't require us to do the flywheel. Mainly what happened is most of the compressor we have flywheel, right? Flywheel is actually, you read through the course note, actually tell us the story, right? In order to cater for the peak, you have a flywheel in order to smooth, right, the process. So over here, I just want to highlight, same thing like what we learned for the load factor, right? You have to find the average, right? Because this is the top throughout the process, so you have to find out this the average top value. So you consider this as the integral of the net steady torque because of this chart. So you have to apply this formula. You need to know how to apply this formula. Right. So basically similar to our load factor concept. Right. Because of the torque value changes, you find the average. So this is what happened at the energy surplus and energy discredit or deficiency. Right. So what happened is later on you have to use this formula. So take note of this because it's a favorite question. You need to know how to use this formula. Inertia, especially at the inertia. We talk about inertia is this one. They love to ask this question, inertia equal to? So this is your because V2 plus BA is this, the radius. Angular velocity this one. Alright, so depending on the thickness of your flywheel, inertia changes, right? Depending on the radius from the center. Right, so just now we talked about formula A and B. Is the radius, in this case inner radius and outer radius. Alright, any questions so far from class? You no question?